Hey guys, welcome to our new unit, which is all about naming and writing compounds. Today we're going to start off with learning how to identify types of compounds. There are 4 main types, and we're going to find out all about them. I'm going to be going through some notes. If you'd like to find these notes, they are on the website, or you can just follow along and learn as you go. First things first, what is a compound? Compounds are formed when atoms either transfer or share valence electrons. Valence electrons are those on the outside shell of the atom, so on that very outer ring. When atoms share or transfer those valence electrons, it creates a chemical bond. And there are a few ways this can happen. Electrons can be transferred between cations and anions. I'm going to make cations red here and anions green. Remember, cation means something that is positive. Cation is positive, and anion is something that is negative. Or those electrons can be shared between 2 anions, a negative and a negative. Note that cations will never form compounds with other cations. You can't have 2 positive things going together. They're both trying to get rid of electrons, and those electrons will have nowhere to go, so it just doesn't work. So the only 2 possibilities are transferring with a cation and an anion, or sharing with 2 anions. Now we do have to learn here about a new type of ion. It's a weird thing called a polyatomic ion. That word's right there, polyatomic ion. This is a group of atoms that are working together and pretending to be one. Here I've put, it's basically like an atom posse. They have an oxidation number or an ionic charge that is for the whole group. And there should be a list in your reference materials, somewhere in your Google Classroom. Your teacher should have provided you somewhere, somehow, a list of polyatomic ions. If they did not, please email them, get them to send one to you. It should look a little something like this thing I have on my page over to the right. It says polyatomic ions at the top. It's got a list. We're going to look at carbonate here, which is, let's see, right here on the list. There is carbonate, CO3 with a -2 at the top. So what that basically means is that you've got 1 carbon that is stuck together with 3 oxygens. That's why it's CO3, because there's 3 oxygens. And together as a whole group, they're going around trying to find 2 electrons to steal. They all together want to steal 2 electrons. They're missing 2. So they've got a little 2 negative as their oxidation number. So they behave just like a single element in that they're looking for some electrons, or some other ones are trying to steal electrons. And that oxidation number, that ionic charge, goes for the whole group, not just one of the atoms there. And you will always be provided this list to refer to, so you can check out the ions on there anytime you need. Now we're going to look down here at this little practice just to make sure you know what you're doing. If you want, you can pause the video and you can try to go through these 15 items, say if they're positive or if they're negative or if they're polyatomic. If you don't know how to do that, you might want to go watch a video or something on how to find the ionic charges or the oxidation numbers of elements. It's also on the top of your periodic table if you filled that out previously in another unit, so you can find it there. But if you want, pause, figure all that out, write down if these are positives or negatives, circle them if they're polyatomic, and check with my answers that I'm about to do right now. All right, so there you can see the answers. I've got red pluses for the cations, green negatives for the anions, and then all of the polyatomic ions, which are ones from this list, are circled in black. So if you're confused about that, email, figure something out. But these, you have to know, they are super imperative for everything for the rest of this unit. All right, so down here, we're gonna look at how this actually happens. And we're gonna do this for sodium and chlorine. So sodium is in group 1, which means it has 1 valence electron, looks like that. And chlorine is over in group 17. It's got 7 valence electrons. It looks like this. Now, according to the octet rule, atoms either want to lose all of their valence electrons to drop down to the next level, or they want to have a full 8 valence electrons. So right now, neither of these elements are quite there yet. Sodium is trying to get rid of its 1. Chlorine is looking for 1 to fill it. So the natural thing to happen would be that sodium is just going to give chlorine its extra little electron, and then they're both happy. Sodium has gotten rid of its 1, chlorine has an extra 1, the octet rule is fulfilled, and you end up with sodium chloride, which is table salt. Now this can happen in a lot of different ways. We're going to take magnesium and chlorine as another example. Magnesium has 2 valence electrons, and chlorine has 7 still. Draw those in there. And you thought Lewis dot diagrams were going to go away. They never do. Okay, and chlorine is missing 1. So magnesium, trying to get rid of it, says, I'll send you 1 of chlorine. But now chlorine is full, and magnesium still has another electron to give. What's going to happen is chlorine, another chlorine atom, a second chlorine atom, is going to come along with another empty space. And magnesium is going to send its other electron there. So this means that magnesium, 1 magnesium atom, is going to require 2 chlorine atoms in order to be happy. So you'll end up with magnesium chloride, which is MgCl2. We're going to look at that in depth later. But this is what is happening with that transfer of electrons. An atom that's trying to give away its electrons is going to pair up with an atom that's trying to take electrons. The other type of bonding happens when atoms share electrons. And this picture is not a great representation of that. You can use Lewis dot structures to represent these and figure out all the bondings. And if you are in pre-AP, you will actually do that. But if you're in regular, all that you need to know is that when 2 anions get together, that is 2 negative things that are both trying to steal electrons. I'm going to write that up here, trying to steal electrons. Instead of giving away or taking electrons, they'll actually decide to just share electrons. And you can see that with these 2 atoms. Between the 2 of them, there are 14 valence electrons, which means there's 7 apiece. So each one is looking for 1. And instead of taking 1, they can just overlap and share these 2 right here. So now they each have 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So they're both happy sharing those electrons. Now we're going to do a little bit of practice down here, figuring out if things are going to share or transfer. So what you need to do is look at each element or polyatomic ion, whichever, and decide if it's positive or negative, and based on that, if it's going to transfer or share electrons. So I'm going to give you a minute to try to do that. Pause the video, try to fill out this chart on your own, and I'm going to write out the answers. All right, so I've got the signs written out here. We're going to start with this top one, lithium and carbonate. Lithium has a positive charge. It's trying to get rid of electrons. And carbonate has a negative charge. It's trying to steal electrons. So a positive and negative, where one is trying to give and one is trying to steal, are going to transfer. The next one is phosphorus and sulfur. Phosphorus is negative, so it's trying to steal. Sulfur is negative, so it's also trying to steal. Since neither is going to give up any electrons, they're going to have to settle and share. Next, with nitrogen and fluorine, again, they're both negative, both trying to steal, so they're going to have to share. down here with ammonium and oxygen. Ammonium is a positive ion, and that one's polyatomic, so you'd have to go look it up on the chart. It's positive, it's trying to give away electrons, and oxygen's negative, it's trying to take electrons. So they're going to transfer. And lastly, this one's a little bit tricky. There's rubidium and strontium. They're both positives. They're both trying to get rid of electrons. So what's going to happen? Nothing. They are not going to bond. They can't, because there's nowhere for those electrons to go. So now that you know kind of a little bit how bonding works, we're going to talk about the actual types of compounds. There are 3 types of compounds that are going to transfer electrons. They are ionic, acids, and bases. And we're going to learn a whole lot about acids and bases way later in the year. Right now, we're just going to kind of look at them on a surface level. The only type of compound that will share electrons is called covalent. Covalent compounds are formed of 2 nonmetals, which are the anions. And the way you can remember those is that they cooperate and share electrons, so they are covalent. Cooperate, covalent. And we're going to summarize those down here in this chart. This is not one you can fill in on your own, so don't feel like you need to pause it. I'm just going to show you how they work. So the first type is ionic compounds. Now, ionic compounds start with, and when I say starts with, I mean the compound, which might look like this, sodium chloride. The first thing in it is what it starts with. So this one would start with sodium. Ionic compounds are going to start with a metal or a polyatomic. I'm just going to put poly so I can fit everything in there. And an ionic compound will either end with a nonmetal or a polyatomic. And ionic compounds are ones that transfer. So like if you look at sodium chloride down here, it's got sodium and chlorine. It starts with sodium, which is a metal, and it ends with chlorine, which is a nonmetal. So this one is an ionic compound. The next type is acid. So acids are special. They only start with one specific element, and that element is hydrogen. If it starts with hydrogen, it's an acid. There is one exception to that. That one exception, which I'm going to mark with a little green asterisk down here, is H2O, water. And I'll talk a little bit about that at the end if you're interested. Water is an exception. Anything else that starts with hydrogen is an acid. And acids can end with a nonmetal or polyatomic. And acids will transfer electrons. After acids, we have bases. Bases can start with a metal or a polyatomic, just like ionic can, but bases always end in hydroxide, which is OH from the polyatomic ions list, and they will transfer electrons as well. Everything transfers except covalent. The last type, like I just said, is covalent. Covalent will always start with a nonmetal and will always end with a nonmetal. And they don't transfer, they share their electrons. An example of covalent would be like CO2 or NO3. 2 nonmetals that are together are covalent. Hopefully that is helpful for you. There should be a practice in your Google Classroom that says starts with, ends with, or if you're in Miss Whiteley's class, it may be titled something else. So go get started on whatever practice you have to do.